For the first kinematic equation, we want to try to find velocity. We can use the equations we already know to help us get there. We know that velocity is delta d over delta t. We also know that velocity is v naught plus v over 2. Change in velocity is final velocity minus initial velocity. So to find the first kinematic equation, what we want to do is we want to start with acceleration. Acceleration equals delta v over delta t. Since we know what delta v is, we can plug in this for that. So acceleration equals v minus v naught over delta t. If we want to try to get velocity alone, we have to get rid of this. So we can multiply both sides by delta t, getting acceleration delta t equals velocity minus velocity naught. So if we add v naught to both sides, we would get that velocity equals v naught plus acceleration delta t. This would give you the first kinematic equation. In finding the second kinematic equation, we would be trying to find distance. We know that velocity equals v naught plus a delta t. And this is the first kinematic equation. We also know that v equals delta d over delta t, and that v equals v naught plus v over 2. So what we can do is we can make these two equations equal each other, getting delta d over delta t equals v naught plus v over 2. We know that v equals this, so we can also plug this in for that. So delta d over delta t equals v naught plus v naught plus a delta t over 2. Given that these both are the same, we could combine like terms. So delta d over delta t equals 2 v naught plus a delta t, this over 2, and this over 2. We can cancel these out, and we still want to try to get rid of this, so what we do is we multiply both sides by delta t, giving us that delta d equals v naught delta t plus a delta t squared over 2, or we could say 1 over 2. So this is your second kinematic equation. In trying to find the third kinematic equation, you are as well trying to find velocity. From the second kinematic equation, we know that delta d over delta t equals v naught plus v over 2. If we cross multiply, we would get 2 delta d equals v naught plus v times delta t. What we can do is divide both sides by v naught plus v, getting delta t on its own, making delta t equal 2 delta d over v naught plus v. We know that acceleration equals v minus v naught over delta t, because acceleration equals delta v over delta t. And this equals this. So delta v, oh, never mind. So if we want to try to get delta t by itself, using this right here, we multiply both sides by delta t. So let's move this right here. Acceleration equals v minus v naught over delta t, multiplying both sides by delta t. So a delta t equals v minus v naught, because these cancel out on this side. Now, what we can do is divide both sides by a, and we get that delta t equals v minus v naught over a. But now we have this equation and this equation, and they both equal delta t. So we can set these two equations to equal each other. So 2 delta d over v naught plus v equals v minus v naught over a. If we cross multiply these, then you get 2a delta d equals v naught plus v times v minus v naught. What you want to do is you want to FOIL both of these. And what you would get is 2a delta d equals v times v naught plus, minus v naught squared plus v squared minus v times v naught. This right here and this right here can cancel out because you would adding something to something negative. So you'd get 2a delta d equals negative v naught squared plus v squared. If you add v naught squared on both sides, you would get v squared equals v naught squared plus 2a delta d. And this right here is your third and final kinematic equation.
Now that we have learned how the equations came about, the question comes to when and how do we use the equations. Overlapping in these three equations, we have velocity, which is usually the final velocity, and then we also have initial velocity, and then time, acceleration, which is 0 for horizontal motion if you ignore air resistance, and negative 9.8 for vertical motion, which is also gravity. And last but not least, displacement or distance. We have initial as well as final. To summarize, these are the 5 variables that occur in the 3 kinematic equations. For the problems we see, usually we're asked to find one or more of these variables. So one strategy to find which equation to use is look at the variables that are known and find and see in the equation that which variable you don't know, to eliminate as few as possible of the unknown variables.